Good morning, afternoon, evening, depending on when you tune in. How you doing today? Hope you're all hanging in there. I wanted to talk a little bit about the evolution timeline assignment that we did. I got a lot of good stuff, but there were some definite things that didn't happen that could have happened. And that's specifically connections. A lot of people put information about some of the required individuals, and then also um, some people found some great references to other individuals that have contributed to the theory of evolution or had an influence on it. Um, but what didn't always happen was a mention of how those people connected their theories to evolution, or how somebody like Charles Darwin was influenced by those theories. So I just want to go through and make some of those connections for us. Um, so the big concept here, and one of the things you should have gotten from this timeline that I don't think everybody did, was how do these events sort of contribute to the theory of evolution, and this idea that how science works, which we sort of talked about in Unit 1. um, the theory of evolution gives us a really nice context to look at that historical development of different scientific theories. And so that connection was missing from a large number of the timelines that I read. When we're doing work like this, we need to constantly add to material that we find online in the sources that we're using, and that helps us make it our own. So sure, you're getting information from a source, and a lot of that stuff was cut and pasted, which is questionable as an academic process. But if you're going to do that, you need to do something that shows you thought about it, you process that on your own, if you're going to just cut and paste. And so you need to take that idea and connect it to what you are doing. In this case, a timeline about evolution. So how does it connect to evolution? And that gets to be the big question. So one of the first is Carolus Linnaeus. He is the originator of our modern classification system, and while it's gone through many revisions since he originally developed it, Linnaeus was the first to do it. He gave us a binomial system with genus and species names. He was the one that Latinized everything, because Latin was a language that was common to much of the world at the time. And unfortunately, that's a very Eurocentric perspective. But because in the ancient civilizations, the Romans conquered so much of the world, including Northern Africa and all the Mediterranean area, as well up into England and Germany. Like, Latin was pretty common way back in the day for most of Europe. Um, so it works. It's what we're stuck with. But this idea of classification is important to evolution, because this is when we start to think about how things relate to each other, because that's what Linnaeus did. In naming, he started looking at features, and when coming up with this hierarchy of classes and orders and families, things were grouped by commonality. And that then starts to develop this idea of there are similar features that all organisms have that make them related, and there are different features that organisms have that separate them. And that's one of the big things that a theory of evolution will need to do, is show those differences, but at the same time showing similarities. Thomas Malthus was one of the required individuals. He was an economist. He studied the flow of money. And so very often this idea of, well, how did he get involved in this theory of evolution? And he had a direct influence on Charles Darwin. His ideas about population growth and the limitations to those population growths, especially food supplies, were a huge influence, because Darwin did this reading. This is one of the reasons it's really important to just read in general. Don't limit yourself. Read what is out there. from many, many different sources, from many, many different authors. Darwin was a naturalist, and he was reading books on economy, and it's not something you would expect, but it adds to your understanding of the world. And a lot of times you'll make connections like this, where Darwin saw, hey, if this is true for human populations and economic situations where populations get bigger and bigger, but they can only get so big before the supplies run out, that this really set up Darwin for his idea that there's going to be a struggle for resources, that organisms will overpopulate, and that that's going to be limited by the environment, which is really, really important into the theory of natural selection. Gregor Mendel, the grandfather of modern genetics, did all the works with pea plants and used all the Punnett squares and did all the crossbreedings. He gave us a whole lot of information about how traits are inherited and when things go from parent to child, what patterns they have. It helped disprove Lamarck's idea of acquired characteristics, and those patterns of inheritance really helped reinforce a lot of the things that Darwin was talking about. But the two of them were nowhere near. They were about 100 years apart in a timeline. And Gregor Mendel did his work long, long before Darwin, but it was rediscovered after. And when people looked at it, they said, hey, these two different people have ideas that can be combined. And Gregor Mendel really helped put a little bit of a solid mechanism, a solid reason how, or explanation of how traits get inherited, which was a big stumbling block for Darwin. Lyell and Hutton, they were both earth scientists. They studied geology. They are contributing gradualism and uniformitarianism to science. Gradualism is this idea that things happen slowly over time. And Darwin adopted that idea into evolution, and it really set things off, because as people accepted the idea that the earth could change over time, that led to this, well, if the earth and non-living things can change over time, well, why can't living things change too? And that got to be part of the theory of evolution. That was one of the big pushes that allowed people to accept this. It was okay for the earth and non-living things, but then it must also be okay for living things. And that goes to this idea of uniformitarianism. Uniformitarianism states that the forces that are shaping the earth today are the same forces that shape the earth historically, and the same forces that are going to continue in the future. So we can apply both of those concepts to evolution. And Darwin did, saying that this process of evolution is happening now. It's going to happen as we continue, and it's also happened in the past. And it's uniform. It's always the same. It hasn't changed. And then that idea of gradualism. Turns out that Stephen Jay Gould, who many of you put into your timeline, who's actually at the American Museum of Natural History here in New York. That's where he worked. He didn't live there, but he definitely worked there. He questioned this idea of gradualism, and one of his big ideas was that maybe evolution happens really, really fast, in quick bursts, and then we go a long time without anything, and then we have another burst of evolution. And this is called punctuated equilibrium, and it challenged this idea of gradualism. So there have been changes, and there still is a lot of debate about how evolution happens, particularly in that sense. James Watson and Francis Crick, of course, they gave the structure of DNA. A lot of people put them on the timeline. But what does DNA have to do with evolution? The answer then gets to be that anytime we have DNA connected, DNA is our molecule that passes information from parents to offspring. So it goes back to this idea that was pushed by Mendel, that we inherit certain traits from parents and that these parents get passed. The important connection to evolution is this idea that those traits can give organisms a survival advantage, which is really, really important in the idea of natural selection. any scientist we can connect to DNA discoveries, whether it's structure or function, is going to have that same sort of connection that we see. And in our modern world, yeah, we use DNA sequences to look for similarities between organisms for classification. We look for protein similarities to look for classifications and group things together. And it's become a really, really important part of finding evolutionary history, is looking for those commonalities that we see. Fossils came up pretty often, whether it was discovery of fossils like Lucy or Neanderthals. Um, uh, the fossil record is considered one of our major pieces of evidence supporting evolution. It allows us to see that organisms are uh, extinct, that we see fossils from things that are no longer alive, and therefore we need to be able to explain how they went extinct. And that is the other side of the whole natural selection. If you do not have traits that are going to allow you to survive in the environment, then you are not going to survive to reproduce. And if that happens repeatedly, year after year after year, well, extinction happens. And sad for the dinosaurs. But now we have oil and gas because of that. So maybe it's not all bad for us. Okay. This has been a quick overview of some of those things. It would be worth it if you go back and look at your timelines, kind of see where you can make those connections that you might not have made originally, just to sort of put this in a context and get a really complete understanding. Okay. Have a great day. I will speak to you all later, and I hope you're doing well.